So far, we've defined machine learning, reviewed the importance of quality data, and explored a few Google ML and AI offerings. In this video, I'll cover 4 common business problems that ML is particularly suited to solve. In each case, ML is uniquely placed to create new business value when it can learn from data to automate action and processes, and to customize responses to behavior. The 4 common business problems are replacing or simplifying rule-based systems, automating processes, understanding unstructured data, and creating personalized customer experiences. Let's start with the rule-based systems. I'll use Google Search as an example. Suppose, for instance, you want to search for the Giants, a sports team. But wait. If you type in Giants, should the search results show you San Francisco Giants or New York Giants? One is a baseball team based in California, the other is an American football team based in New York. A few years ago, the search engine Codebase used hand-coded rules to decide which sports team to show a user. If the query is Giants and the user is in the Bay Area, show them results about San Francisco Giants. If the user is in the New York area, show them results about New York Giants. If they're anywhere else, show them results about tall people. This is for just one query. If you multiply this by thousands of different queries and by different users each day, you can probably imagine how complex the whole code base would become. This is a perfect problem for ML to solve. If we had all of the data that tells us which search results users clicked on per query, why not train a machine learning model to predict the rank for search results? That was the idea behind RankBrain, Google's deep neural network for search ranking, which was introduced in 2015 by Google's engineers. It outperformed many human-built signals, and using ML, Google was able to replace many of the hand-coded rules. The neural network ended up improving search quality dramatically. In fact, Google's neural network is a key differentiator among similar technologies in the market. An added benefit of RankBrain, or any machine learning model, is that the system could continually improve itself based on new user queries and new user clicks. Search is one example of how ML leverages vast amount of data to provide highly accurate predictions in a rule-based system. A second opportunity for using machine learning is to automate processes where ML makes predictions and repeated decisions at scale. Let's look at an example. Ananda Development is a property developer headquartered in Thailand that decided to use ML to automate the handover stage of their property sales. Before embracing cloud and ML, the handover process included multiple manual steps and was prone to errors. In any sale, before the buyer paid for the property, an Ananda Development inspector and the buyer had to conduct a detailed check of the condominium for any building variations that needed to be fixed. Ananda Development inspectors would visually check hundreds of items a day for problems and list any issues on paper. Prospective buyers might also take notes and photographs of the findings. On average, a single inspector would have to check several hundred items per day. Multiplied across several inspectors and multiple projects, this workload adds up. This laborious manual process was also subject to occasional human error that meant data could be omitted or recorded incorrectly. Ananda Development decided to build an app using machine learning to make the inspection process more efficient. The app used Google's Speech-to-Text API to recognize and convert Thai language speech and a version of English spoken by many Thai people to text. The company found the product had an accuracy rate of over 90% in recognizing Thai speech and high accuracy rates in recognizing Thai English. The inspection process is now more efficient and accurate. As another benefit, buyers also receive copies of electronic inspection reports and updated status notes as defects are repaired. Another class of ML use case is for understanding unstructured data, like images, videos, and audio. Before I dive into examples of how you can use ML to understand unstructured data, I need to acknowledge a key point. So far in the module, we've been talking about a specific type of ML that uses structured data to make predictions at scale. Now I'm going to cover how ML can also be used to understand unstructured data. Unstructured data is data that can't be directly compared to other data. For example, some characteristics of books are structured, like the title, their publisher, location of publishing, number of pages. Again, this is known as tabular data. But it's not easy directly to compare the content of the two books or to precisely determine how they are related or different. Even human experts might not agree on exactly how similar two books are. Open text or language is just one example of unstructured data. Other examples include pictures, videos, and audio. A great example of using ML for unstructured data comes from Ocado. Ocado is one of the world's largest online-only grocery supermarkets. Previously, all email sent to Ocado would go to a central mailbox for sorting and forwarding by a person. This process was time-consuming and would lead to a poor customer experience. To improve and scale this process, Ocado used ML to automatically route emails to the department that needs to process them. This new process eliminated multiple rounds of reading and triaging. Here, Ocado used ML to both automate a process and understand unstructured data. Specifically, they used ML's ability to process natural language to identify the customer's sentiment and the topic of each message so they could route it immediately to the relevant department. Now let's look at a fourth example, personalization. Many businesses use ML to personalize user experiences. Personalization is the difference between a newspaper and an email. A newspaper article can be interesting, but it's written to appeal to thousands or millions of people. However, an email is often tailored just to one person, by including their name, for example. YouTube is a great example of personalization in action. When you watch a video on YouTube, you'll probably notice on the homepage or to the right of your video, there's a list of recommended videos that are up next. When your video finishes, these new videos will play, and we'd like them to be interesting and useful for you. This feature keeps the user interested and engaged with the product. By providing personalized recommendations using ML, YouTube can deliver a better service to their customers while also increasing their ad revenue. Many businesses use the same approach to feature product recommendations on their websites personalized to individual users. Other businesses use personalization to surface new content, like music recommendations or films to stream. Great, let's do a recap. So far, I discussed some common applications of machine learning, such as replacing rule-based systems, automating business processes, understanding unstructured data, and personalizing applications. It's important to remember that ML models aren't standalone, and that solving complex business challenges requires combinations of models. There are, of course, many more applications of machine learning for businesses, and you can learn even more about them in the course, Managing Machine Learning Projects with Google Cloud. Next, I'll summarize the key topics we covered in this course.